Welcome to today's lesson. Today we're going to learn Born-Haber cycle. What is Born-Haber cycle? This is a cycle that applies the laws of Hess or Hess law. Using this Born-Haber cycle, we are going to calculate the lattice enthalpy of a solid. In practical life, it is not possible to make 1 mole of solid lattice from their ions, gaseous ions. That is not possible. So how do you calculate it? You calculate it using Born-Haber cycle. But in question, sometimes you would see that the lattice enthalpy value is given and you have to find the other values. So let's start so that we understand what is the requirement. Imagine you want to make a solid lattice, 1 mole of solid lattice. What is the best thing to do? What you are going to do? You are going to naturally, you're going to add sodium solid and chlorine gas and react them together to make 1 mole of sodium chloride. So Na solid plus half Cl2 gas is equal to NaClS or solid. And here we call it the formation reaction, right? We are forming a lattice from their elements in their standard state, right? Sodium standard state is solid and chlorine is gas. Now when you are doing this, the energy changes obviously delta H of formation of sodium chloride, isn't it? We have learned it already, right? Now that's one option to make sodium chloride from sodium and chlorine. But there is another way where you can make sodium chloride solid lattice, and that is an indirect way. How can you do that? Well, we can make sodium and chlorine, we can make both of them in several processes. We can make them gaseous ions. And then we can add this gaseous ion to make solid lattice. So you have sodium solid and chlorine gas. How are you going to convert it eventually into sodium gaseous ion and chloride gaseous ion? How are you going to do that? We need to first convert sodium into gas, sodium gas. Then from sodium gas, we are going to make it sodium ion. Likewise, Cl2 is already gas. So we are going to make it first from molecule. We're going to make it into atom here. You can see that half Cl2 becomes chlorine atom. And then from that chlorine atom, we can make a chloride ion by taking out electron from it. And then we can react these two ions together. Now let's start. Let's see from here. You have sodium solid and half Cl2 gas. First of all, we'll not bother about chlorine. See that in this 3 process we did not bother about chlorine. It's the same thing. But first we are going to make sodium solid into sodium gas. And you know already, I discussed that, if you're going to make 1 mole of sodium solid into 1 mole of sodium gas, the energy change is called enthalpy change of atomization, right? When you boil, when you melt, then make it vaporize the sodium solid, it will become atoms, right? From a lattice sodium metal, it will become atom. So this is enthalpy change of atomization of sodium, from sodium solid to sodium gas. Now, from sodium gas, you're going to make sodium ion. How can you do that? by taking out one electron from it, right? And what is the energy change when you do that? Obviously, ionization energy. First ionization energy of sodium. Simple, isn't it? Okay, now see, I did not change anything in half Cl2, Cl2, Cl2. Now my goal is complete. I have got what I wanted, sodium ion. But I start changing the chlorine now. Now from half Cl2, I need to make it atom first to make it ion. So half Cl2 to Cl, what is that? Enthalpy change of atomization of chlorine. Chlorine usually stays as molecules, right? If you want to make it atom, you need to break the bond, right? So here you're changing half Cl2 into Cl, half Cl2 into Cl. And this is called enthalpy change of atomization for chlorine, because you are breaking the molecule and making atoms. So half Cl2 becomes Cl. Now from this Cl you want to make it now Cl ion, right? How can you make chlorine into chloride ion? Well, you give it the electron, and when you are giving electron, I already discussed that, to a gaseous atom to make it negative ion, we call it electron affinity, right? Electron affinity, first electron affinity of chloride. So here you get sodium plus and Cl minus. The energy change is written here. Now you have sodium gas and chloride gas. If you add them together, you get sodium chloride. And this energy change is already, you know that it's lattice enthalpy, right? From gaseous atom ions, if you want to make 1 mole of solid lattice, it is called lattice enthalpy. Lattice enthalpy. Now here's the thing. According to Haas, you started with sodium solid and chlorine gas. Now you first make in a direct way, it is written as red color, you directly make sodium chloride. And you have another way to make the sodium chloride. You do not go this way, you go this way. You make this one, this, then you make this one. So this is a direct way and this is an indirect way. The beginning and the end is the same. And according to Haas, if the beginning and the end is same, no matter what way you go, the energy change is always equal. So can I write delta H formation of sodium chloride is equal to, this directly is equal to this one plus this one plus this one plus this one plus this one, right? Can I write delta H of atomization of sodium plus, here is delta H of ionization energy, one of what? Of sodium, plus, can I write delta H of atomization of chlorine? Atomization of chlorine plus delta H of electron affinity. Electron affinity plus delta H of Le. Delta H of, I'm done. So this is the Haas law. And this is the Born-Haber cycle. Now, if these things are, you know this thing, this one, 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 and this one, from that you can easily calculate lattice enthalpy without having to do it practically. You can actually do this, and you can find this one. It's so easy. Now here is the question. Number 1, enthalpy change of atomization of sodium, it will be given in the question. Ionization energy, it will never be given in the question. Why? Because you can find it in the data booklet that will be given to you. So this figure will be given to you in data booklet. Now this one, it will also not be given in your question paper. You need to look at the data booklet for that value. You can ask, sir, why not? And we do not see any atomization energy in our data booklet. There is no such thing as atomization energy. Well, here's the thing. If you see half Cl2 becomes Cl, you look at the bond energy of chlorine, you will find it, the bond energy in your data booklet. You make it half, whatever, say it's 400, I don't know the figure, it's 400. You will take it as 400 divided by 200. Why? Because it's half Cl2 making 1 Cl, but is the bond energy between 2 Cl, so you have to make it half. So half Cl2 Cl atomization of chlorine is the half of bond energy. Now electron affinity, it will be given in the question paper. Lattice enthalpy not given because it's what you wanted to do, find out. Now enthalpy change of formation, definitely it will be given. Now in A level, they also may give you the figure Le and delta H of formation, and they may ask you to find out the delta H of atomization of sodium. You all know all of this thing, you put in the equation, and eventually you'll be able to find this value. Now